Hello and welcome to yet another thrilling installment of the Algebra 1 videos. This is Unit 4 and this is Section 3, and we're going to be solving systems of linear equations using what's called a linear combination method, which I often just refer to as elimination, okay? I don't know why they call it that. This edgenuity is weird. All right, so what we want to do is we want to solve a system of linear equations using linear combinations. We want to be able to interpret that solution in a modeling context. So, you know, these 5 steps right here give us the method on how to do this, given 2 equations, typically in standard form, okay, where x and y are on the same side of the equal sign. So what we want to do, we want to create coefficients that are additive inverses on one side of the variables if needed. And by additive inverses, that means opposite coefficients. Opposite coefficients, okay? Coefficients. All right, so then what we want to do is then add the equations to eliminate one of the variable terms, solve the new equation for the remaining variable, and then substitute it back into the original equation to find the value of the other variable, and then we want to check our solutions. Okay, so what we want to do here, I'm going to go in here. We want to solve this equation. 3x minus 7y is equal to 5, and then the other equation is 5x minus 9y is equal to negative 5. So what I want to do is multiply this equation by something and this equation by something so that we get opposite coefficients, okay, additive inverses. Now, the method that I would typically use here is try and use the smaller numbers. That's just kind of my general rule of thumb. But what I want to do is, and the way you'd want to do it, the kind of the idea is to take this equation and multiply it by the opposite coefficient that you're looking for. So if I want to eliminate the x terms, okay, this is a 3 and 5. I can't multiply 3 by anything to get 5. So I'm just going to multiply 3 by 5 itself, okay? So I'm going to do that here. Now, the other thing I want to do is multiply this bottom equation by something so that we get the opposite. Now, because... Okay, so what I want to do is then multiply this equation down here by negative 3. So one of them has to be opposite of the other. Now, it's just that only works when you have the same sign here. If you have different, if they have opposite signs, then you just multiply by the numbers. Okay, so now what I'm going to do is I'm going to distribute my 5 into each of these terms. So I end up getting 15x minus 35y is equal to 25. Okay? And then I'm going to take negative 3 and multiply that through on the second equation. And that's going to give me negative 15x. And then positive 27y. And then we get positive 15, okay? Now, the reality is that I want to get opposite coefficients here, okay? And that's the point, is to get a 15 and a negative 15 here. And then I'm going to add these together, okay? And so if I do 15x plus a negative 15x, that adds to 0, or hence gets eliminated. Okay? So that goes to 0. All right, and then you have negative 35 plus 27, and that's going to give us a negative 8y. And that's going to be equal to 25 plus 15, which is going to give us 40. Okay, so now what I've created here is I've eliminated the x variable, and I only have y. So now what I can do is I can just solve this for y. I'm going to divide by negative 8 and divide by negative 8. And I end up getting that y is equal to negative 5. Okay, so now what I do is I take this value for negative 5, and I'm going to plug this back into one of the other original equations. It doesn't matter which one you choose. I typically choose the one that has the smaller numbers, okay, easier to work with. So I'm going to do this. I'm going to do 3x minus 7 times y. But instead of writing y, I'm going to write what y is equal to, which is negative 5. Okay, and then that's going to equal positive 5. All right, so now I've got 3x. Negative 7 times negative 5 gives me positive 35. And that's going to be equal to 5. All right, so then what I'm going to do is I'm going to subtract 35 from both sides. and solve for x, and so I get 3x is equal to negative 30. Divide by 3, divide by 3, and so I get that x is equal to negative 10. Now remember, we're out to get an x value and a y value, so we write this as an ordered pair from negative 10, negative 5. Okay, now what I'm going to do is I'm going to graph these to just verify that we do have the intersection point of negative 10, negative 5. So I'm going to go into Desmos, graph those, and be right back. All right, so after I've graphed this, we do in fact have a verification that we did get this correct. We have the point negative 10, negative 5, and that's what we got algebraically here by using the elimination method. Okay, this is really fun. I'm having a good time. Okay, on this next section, what I want to do is talk about the types of solutions of a system of linear equations. We can get something where we have one solution, no solution, or infinitely many solutions. And I want to do this algebraically. We're good at figuring how this works, graphically, but I want to do it algebraically. So let's look at each of these systems of equations. And what I want to do here is kind of, solve these equations using elimination and kind of show you what we'd get. So what I want to do here, on this one, I have these two equations, negative 6x plus 4y equals 2. And we've got x plus y equals negative 2. Okay, and what I'm going to do is I'm going to take this, I'm going to multiply this whole thing by positive 6. Okay, I'm going to eliminate the x, all right? And so when I do that, I'm going to distribute my 6, and so I distribute to each of those pieces, and I end up getting positive 6x plus 6y is equal to negative 12. Okay, and when I add these together, all right, the negative 6x and the 6x add to 0. They get eliminated. 4y plus 6y gives us 10y. And then 2 plus negative 12 gives us negative 10. Okay? Divide by 10, divide by 10. And so then we get y is equal to negative 1. Okay? Now, I can take this and I can plug this back into the y here of this equation. Okay, and I'm going to go ahead and do that. So I get x plus y, but instead of writing y, I'm going to write negative 1. All right, and that's equal to negative 2. And if I add 1 to both sides, then I get that x is equal to, what is that, negative 1? Okay, so y equals negative 1, x equals negative 1. I have a solution. I have 1 point here, negative 1, negative 1. Okay, and we can see that we get that same thing from the graph. We get the point negative 1 here, all right? So that means we have a solution, okay? If we actually get values for x and y, that means we have solutions. And now let's look at something where we don't get a solution, all right? So what I want to do here is I'm going to multiply this entire equation here by a negative 2, okay? I'm going to eliminate the 6, or the x term. So what I'm going to do, I'm going to take this, I'm going to multiply this by negative 2. Okay, I'm going to distribute that into each of those. And so I'm going to get positive 6x, and then I'm going to get negative 2y. Oh, that's weird. And then I'm going to get negative 8. Okay, now if I add these together, all right, then what's going to happen is I'm going to eliminate the x term, negative 6x plus 6x. That gets eliminated to 0, okay? And then I get 2y plus negative 2y. That also gets eliminated, and we get 0. So I get 0 plus 0, and then that's going to equal negative 12. So then I have this statement here. 0 plus 0 is just going to give me 0, and that's equal to negative 12. Now, this is a false statement. Okay? And so if we get something eventually where we get a false statement, that means that there is no solutions. Okay? And that's that. Okay, now on the next one, I'm going to do the exact same thing. I'm going to go ahead and eliminate my y value, and I'm going to multiply this whole entire equation by negative 2. Okay, because I see I have a 2y here, and I just have a single y here. Multiply everything by negative 2. Now, if I multiply that all out, then this is what we'll get. So I got negative 2 times 2.5, that's negative 5x. And then y times negative 2 gives me negative 2y. And then negative 2 times 1 just gives me negative 2. So then when I add these together, all right, I'm going to end up getting 5x plus negative 5x. That gives me 0, okay? And then here I get 2y plus negative 2y. That also gives me 0. And then I've got 2 plus negative 2, which also gives me 0. Now 0 plus 0 is just 0. So if I get the statement that 0 equals 0, this is a true statement, okay, which means that I have an infinite number of solutions, infinite solutions. Okay, so if you get numbers, all right, from doing this, then you just get an answer. Okay, you get one solution. If you get a false statement from this, where you eliminate both of the variables, then you have no solutions. But if you eliminate both of the variables and you get a true statement, 0 equals 0, then you have an infinite number of solutions. Okay, so hopefully you guys see how I was multiplying and manipulating these equations to get the desired number in order to do this using elimination. Okay, so now let's take a look at some real-world applications. What I have here, it says, write the system of equations, use, okay, yada, yada, yada. In this problem, okay, Mario's family goes to the movies and spends $38 on 2 child tickets and 3 adult tickets. Lou's family goes to the movies and spends $34.50 on 3 child tickets and 2 adult tickets. And so we want to know what is the cost of each type of ticket. So what I want to do is this. Okay, I'm going to let x equal the cost of a child ticket. Okay, and I'm going to let y equal the cost of an adult ticket. An adult, oh, for God's sakes, adult ticket. All right, now, besides the fact that you have, I'm just curious as to the dynamic of Mario's family. Who are these 3 adults? Okay, I would assume that in Lou's family, he's got a wife and 3 kids, but in Mario's family, I mean, they got some sort of like weird uncle or something like that. I don't know. I am the weird uncle. I am the one that would, if I went with my family, okay, I would be, that. They have 2 kids, and there'd be 3 adult tickets. So, I mean, I guess I shouldn't be saying anything because I am the weird one, but I digress. Okay, so let's write 2 equations for this situation here. And let's say that, okay, if I get 2 child tickets for the first one, so 2x plus 3y, okay, that's going to give me a total of $38, okay? On the other hand, for Lou's family, we have 3 child tickets, so 3x, and then plus 2 adult tickets, so 2y. And that's going to give me a total of $34.50, okay? Now, what I want to do is I want to figure out which one, what's the cost of each of these, all right? So what I'm going to do is I'm going to multiply this equation by -3. I'm going to multiply this bottom equation by +2. Okay, so when I do that, I'm going to distribute this -3 into each of those terms, and I'm going to get -6x minus 9y, and that's equal to 38 times -3 is 114. Okay, and then same thing down here. 2 times 3x is going to give me +6x. And then 2 times 2y is going to give me +4y. Okay, and then 2 times 34.5, so 34.5 times 2 is going to give me 69. Okay, so now what I want to do is I can eliminate this term with x. Okay, -6x plus 6x. If I add those together, okay, it's going to go away. It's going to get eliminated. I'm going to get 0. Okay, if I take -9y and add 4y to it, that's going to give me -5y. And then 114, and this should be -114, sorry. -114 plus 69 is going to give me -45. So I get -45 out of this. So now what I want to do is I'm going to divide both sides by -5, and I get that y is equal to +9. So the cost of an adult ticket is $9. So $9 for adults, okay? Then the next thing I want to do is I want to figure out, so if y is equal to 9, I'm going to sub this back into one of the equations. Doesn't matter which one we choose, but I'm just going to go ahead and put it back into this top one. Okay, all my numbers are whole. I don't want to deal with any decimals here. So I'm going to do the top one, and that's going to give me 2x plus 3. Now, instead of writing y, I'm going to write what y is equal to, which is 9. So 3 times 9, and then that's equal to 38. So I get 2x plus 27 is equal to 38. All right, and I'm going to do this. I'm going to subtract 27 from both sides, and this is going to give me 2x is equal to, oh gosh, what is that? Is that 11? That's 11. Nice. Okay, now I'm going to divide by 2 and divide by 2. So x is going to be 5.5. Okay, so a child ticket is $5.50, an adult ticket is $9. And I tell you what, I miss being a kid with these low prices, man. I'll tell you what. All right, that's all I got. But I hope you enjoyed this video because I had a lot of fun making it. We'll see you later. Bye.